Hello, and welcome to another Orca 3D video tutorial. Today, we'll run a Savitzky analysis in Orca 3D, a parametric speed and power prediction included with the analysis module. The Savitzky method is a common way to predict the resistance of simple planing monohuls with a hard chine. It simplifies the planing region to a prismatic V shape. Then, it estimates the dynamic forces and moments from empirical relationships. Performing a Savitzky analysis is easy with Orca 3D's analysis module, which also includes the hull trip analysis for large displacement vessels and the Van Ortmerset analysis for small ships like tugs and trawlers. Let's make sure that the Savitzky method is the right tool for your model. Your vessel should be a monohull, since the analysis doesn't account for the interference between multiple hulls. You should have a planing craft with a hard chine. The wetted portion of the planing surface should be simple. The closer to a prismatic V shape, the better. This means no steps, extreme hull warp, or significant changes in beam. If your vessel has these more complex features, or is a multi-hull, consider instead using Orca 3D Marine CFD. Simulation can provide highly accurate predictions for complex model shapes. Before starting the analysis, make sure to check these few things. Be sure that your model orientation is set correctly. Check this in the Orca 3D Properties window, accessible in the Orca 3D menu, or with the Orca Properties command. Now is also a good time to check your Orca units. Next, head to the Rhino document settings and check that your tolerance isn't too tight. It probably shouldn't be smaller than about 1/10 of a millimeter. Now we're ready to run our Savitzky analysis. Go to the Orca 3D menu, click Speed/Power, then Planing Hull Analysis. First, select the whole hull surface, including the top sides above the chine, for hydrostatics calculations. You can select both sides of centerline or just the half hull. Then, select the planing surfaces on just one side of the hull. In this step, you can select individual faces of your model. Right-click or press Enter to advance to the Input window. The first step here is to define your load case. Here on the right, you can specify the weight and CG. Alternatively, you can use an Orca 3D fixed load case combined with the geometry you selected for hydrostatics in the last step. You can pick from your existing load cases, and Orca will automatically update the hydrostatics. You can add and edit fixed load cases here as well. If you'd like to learn more about Orca 3D fixed load cases, take a look at the load case section of our basic hydrostatics and stability analysis video. Link down below and appearing now as a YouTube card. Use the mirror option if you selected a half hull for hydrostatics. Next, specify the longitudinal center of effort and the vertical center of effort of the propeller, and the shaft angle measured to baseline. You can also pick these right on your model. Next, set the speeds for the runs. Set a min and max and an increment. Remember that the Savitzky method's results are only valid in the planing regime. This minimum speed is well below that. But let's see what happens when you run a slow speed test. Next, you can define margins and efficiency. The resistance design margin allows you to account for the contribution of superstructures, appendages, rudders, and any other items not included in the Savitzky method. For propulsive efficiency, enter your estimate for losses in the propeller, shafting, and transmission. This figure is used for calculating the approximate propulsive power required for your vessel. Now, we are ready to run our Savitzky analysis. Click Calculate. The analysis report will be brought up automatically, but you can access Orca 3D reports at any time by going to the Orca 3D panel, then to the Orca 3D Reports tab, and then clicking on the appropriate report. The report begins with hydrostatics, then lists results from each speed run. The prediction check highlights any speed that Orca 3D has flagged, in our case for being too slow and falling outside the planing regime. The numbers in the check column correlate to detailed notes about the issue, found at the bottom of the page. Those speeds are then also flagged on the resistance plot and on the trim angle plot. You can disable this by unchecking Show Checks in Resistance Plot in the Output section of the Savitzky Setup window. Thanks for watching, and check out the Orca 3D channel for more how-to videos. Got more questions? Get more answers with the help resources in the description.